Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on electricity and radioactivity from October-November 2022, paper 2, variant 2. In the last two videos, we have discussed from question number 1 to question number 5, and for the solution of those questions, you can go to the channel and you can find the solution. Today's video, we will start from question number 6, and we will discuss question number 6 and question number 7. And this is the last video on this paper. Let's study together. Let's improve together. For question number 6, part A, we need to define electric potential difference. An electric potential difference simply is equal to energy transferred. Energy transfer means the potential difference. We can say this is equal to energy transferred per unit charge. Energy transferred per unit charge. So this is how we can define potential difference. And the better way and the precise way to define electric potential difference is we need to talk about the forms of energy. In electric potential difference, we have to write down electrical energy to other forms of energy per unit charge, to other forms of energy per unit charge. So this is how we can define electric potential difference. And now this is what you need to write down for the answer of this question. So let me show you the answer, how you can write down the answer. So this is how you can write the answer for this question. You can say energy transfer per unit charge from electrical to other forms. So you will get 1 mark. For part B, it is given to us a battery is connected to two resistors X and Y as shown in figure 6.1. The resistance of resistor X is greater than the resistance of resistor Y. We need to state and explain which resistor dissipates more power. And for power, we need to understand power is equal to I square times R. So if I is greater, it means power will be greater. If R is greater, power will be greater. Now, first of all, let's look at current. If you look at current passing through these two resistors, current is the same, because these two resistors are connected in series. So first point, simply you can write down same current passing through X and same current passing through Y. Simply you can say same current in X and same current in resistor Y. So this is one point you can write down. And the second point, simply you can copy this formula. You can say as P is equal to I square times R. So this can be 1 point. And the third point, you can say power dissipated in X will be greater because Rx, this one is greater than Ry. So more power dissipated in X. So we can say X dissipates more power. So X dissipates more power. So X dissipates more power. So this is how you can write down your answer. So quite straightforward question, but you need to understand how to write down these steps. This question has 3 marks, so you need to write down at least 3 points. For part C, it is given to us a battery of electromotive force 9 volts and internal resistance small r is connected to two resistors P and Q as shown in figure 6.2. A total charge of 650 coulombs moves through resistor P in a time interval of 540 seconds. During this time, the resistor P dissipates 4,800 joules of energy. The current in resistor Q is 4.5 amps. Assume that EMF of the battery remains constant, and we need to calculate for part 1 current in resistor P. Current in resistor P. Current is not simply rate of flow of charge. The better way to define current is the amount of charge passing through a point per unit time. Amount of charge passing through a point per unit time. So in this case, resistor, you can treat it is given to you amount of charge passing through resistor P in given time. So you can calculate current. So simply we can say I will be equal to the amount of charge passing through resistor P in given time. So this is delta Q over delta T. So delta Q is given to us, that is 650 coulombs, and current in time in this case is given to us, mean this amount of charge passing through resistor P in time 540 seconds. So we can calculate value of current, that is equal to 1/2 amps. up to 2SF. We have to use 2SF because the given data, it has 2SF. So we have to consider least number of SF in given data. So the answer for this question is 1.2. For the second part, we need to calculate the potential difference across resistor P. But energy dissipated in resistor P is given to us, that is equal to 4800 joules. It simply means that this much electrical energy has been converted into thermal energy when Q equal to 650 coulombs passes through resistor. Now we have these things and we need to calculate potential difference. So potential difference simply is equal to work done per unit charge. So in this case, we have total amount of work done divided by total charge passing through resistor. So we will divide by Q. So in this case, we have W, total energy dissipated, that is equal to 4800 joules, and Q is 650 coulombs. So the value of PD, potential difference, we can calculate. That one will be equal to 7.4 volts up to 2SF. So this one is our final answer. So this is how you can calculate potential difference. It simply means that when this much charge will pass through resistor P, this amount of electrical energy, this will be converted into thermal energy. So this is how you can calculate potential difference across any resistor. For the next part, we need to calculate internal resistance of the battery. And we have already calculated current passing through this resistor, that was equal to 1.2 amps. So now we can find out current entering the battery and current leaving the battery. Current entering the battery will be equal to sum of these two currents. So we can simply write down this will be 5.7 amps, and it's better to write down this here as well, because if you write down this step and if your final answer is wrong, still you will get 1 mark for calculating total current in the circuit. So we can say here we have 1.2 amps plus we have 4.5 amps, and total current in the circuit is 5.7 amps. And also current leaving the battery has to be the same, so this is also 5.7 amps. Now we need to calculate value of this resistance, and we have potential difference across this resistor. So if we connect our voltmeter here, let's say this is voltmeter V1, and reading on this one will be 7.4 volts, and we can use this loop now and we can calculate value of R. So we will be using this loop. So we will take this loop. Now simply you need to apply Kirchhoff's second law. I will start from this point. If I go from negative terminal to positive terminal, potential will increase. So the change in potential is positive. So I will write down 9 here. And then when we cross this one, we go in direction of current. It means that potential will drop. So the drop in potential will be 7.4. And now we go in direction of current. So potential also here will drop. So we go in direction of current, so potential will drop. So we will simply write down this is I times R, and that one has to be equal to 0. Because according to Kirchhoff's second law, delta V in any loop is equal to 0. So that's the reason we have written this is equal to 0. Now we can rearrange. We can say 9, this one will be equal to 7.4 plus I times R. I times R. So we can rewrite this one. And value of current passing through this resistor is 5.7. So we can replace I with 5.7, and here we have R. So we need to calculate R. So simply you can write down 9 minus 7.4 divided by 5.7, and this is value of R. So R in this case will be equal to 0.28 ohms, and this is our final answer, and this is how you can calculate. A beautiful way to understand how to approach this type of problem. So simply you need to take this loop because we have potential difference. You can also take this outer loop, result will be the same, but for this one we don't have the resistance. For question number 7, part A, we need to describe the structure of an atom of uranium-238. Structure means we need to talk about protons, neutrons, and electrons. So first of all, let's try to write down the number of protons. This atom has number of protons. So this is number of protons. So simply we can say it has 92 protons. And number of protons in an atom is also equal to number of electrons. So we can say this atom also has 92 electrons. So we can say number of electrons also equal to 92. 92. Now we need to find out number of neutrons. And number of neutrons simply is equal to mass number 238 minus atomic number 92. And the final answer in this case we will get, that is equal to 146 neutrons. So this is what you need to write down for the structure of uranium-238 atom. For part B, it is given to us the decay of uranium-238 is shown by the equation. For nucleus X, we need to calculate the ratio in coulombs per kilogram of charge over mass. Means we need to calculate charge over mass ratio, and our answer has to be in coulombs per kilogram. So first of all, let's try to understand this nucleus X. Here we have proton number, that is 92, and here we have 90. So the proton number of this nucleus is 2. And if you look at the mass number, the mass number of this one has to be 4. So simply this is alpha particle, or simply you can say this is helium nucleus. So we can write down the charge on this nucleus. First of all, charge will be equal to plus 2 times E, and E is the charge on single electron. And the mass of this one, this has 2 protons and this one has 2 neutrons. So we can say the mass of this one, so we can write down mass will be equal to 4U, and 1U is equal to 1.66 times 10 to negative 27 kgs, and value of 1 AMU you can find in the data. If you can remember, it's wonderful. Otherwise you can find on the second page of this exam paper. So this is value of 1 U, and we can also write down this charge. We can say 2 times, and charge on single electron is 1.6 times 10 to negative 19 coulombs. Now simply we need to divide these two quantities and we can calculate charge to mass ratio. So we can simply write down charge over mass. We need to find the ratio between these two quantities. We have charge that is equal to 2 times 1.6 times 10 to negative 19 coulombs, and we need to divide by mass. Mass is 4 times 1.66 times 10 to negative 27, or minus 7 you can say. If we do calculations, our final answer will be 4.8 times 10 to 7 coulombs per kilogram, and this is our final answer up to 2 SF. So this is 4.8 times 10 to 7. So this is how you can approach these problems. The best way to answer problems is read question carefully and try to answer step by step. So in this way you can develop your problem solving skills. Don't just try to use quick method. Try to understand at the beginning step by step, and then you can speed up yourself. So this is a best way to answer these type of problems. And also in your exam, please write down all the steps. Don't use shortcuts. You will lose marks. So always write down all the steps. For part C, it is given to us 2 particles P and Q, each consist of 3 quarks. These quarks are up or down quarks. Particle P has no overall charge, mean it is neutral, and particle Q has an overall charge of plus 2E, where E is the elementary charge. State the quark composition of particle P and particle Q. Particle P, as it consists of up and down quarks and it has no charge, so simply it means that this is neutron. So it has the same quark composition as quark composition of neutron. So this is simply up, down and down quark, mean UDD. So this is how you can write down. If we go to particle Q, the charge on this one is plus 2E. So the quark composition of this one can be 3 up quarks. So it can consist of 3 up quarks. So we can check this quark composition now, means we can check the total charge on particle Q. So we can say the total charge on particle Q will be equal to plus 2 by 3E plus 2 by 3E plus 2 by 3E. So in this case, total charge is equal to plus 2E. It means this is quark composition of particle Q and this is quark composition of particle P. It consists of 1 up quark and 2 down quark, and particle Q, it consists of 3 up quarks. That's all for today's video and also for this paper. If you find these videos helpful, please like and subscribe, because your encouragement is very important to make more videos. See you in next video.